This is a question from Solomon here. This is a long question. So I'll attempt to do this justice. So I've been reading this article on scalability on DHT networks and setting some certain benchmarks that should be aimed for to meet user satisfaction and wider adoption. Benchmarks include systems should scale to tens of millions of active and reachable nodes. Algorithms should account for reduced lookup time and reduced delivery delay. Systems should be able to deal with churn in the order of hundreds of thousands of nodes. In all cases, systems should be able to guarantee 100% success in content resolution. Systems should be able to deal with sudden increase in traffic demand. And there's a link that we can share in the chat if people are interested. So I understand Holochain is building their own proprietary RR-DHT. And is RR-DHT designed to meet the above mentioned benchmarks or even better? And what's its current progress? And also, Art, maybe you could explain the name.
We have some silly names. I don't know that we can explain the name very well. We joke about it being Roadrunner DHT, like meep meep, or Round Robin DHT, or it isn't. There isn't a solid reason for the name, actually. Sorry. One of our devs has a tendency to just kind of make up initials for things and then try to explain them later. But in terms of the question of these performance benchmarks and such, we certainly intend for our DHT to meet all those criteria. I mean, that's key to our scalability targets for dApps in general. But I want to remind that Holochain is not one single monolithic DHT. Every application has its own DHT space. It is its own encrypted network, essentially. So many applications will never be anywhere near having millions of users with churn of hundreds of thousands and that kind of stuff, like nodes coming on and offline. But the fact that DHTs actually can scale to these levels is exactly why we're doing this, because current dApps can't, right? If you go and look at like stateofthedapps.com, you'll see that even the most used apps, dApps, only have a few thousand users. And even their underlying infrastructure, EOS or Ethereum or whatever, simply can't handle millions of users with churns of hundreds of thousands of them coming and going and that kind of thing. I mean, sometimes even just a peak usage, like when CryptoKitties suddenly started getting popular and that kind of thing, it was maxing out the Ethereum network at the time, right? In terms of its ability to actually handle traffic volumes, and that was with only like 2,400 users. So our targets are actually to be able to compete and exceed both in scale and speed with existing DHT platforms. In terms of what's the progress with that, it's really integrated in with the progress of our networking module, because the RRDHT is really a sharding and routing strategy for our network module. That's essentially what it is, because all of Holochain already it's already designed to function as a DHT, and RRDHT is basically just how we do the routing for peer discovery and routing of information, and then sharding of that and gossip of that. And that's all woven in with our network module. And we have been making some really great updates to our network module from lessons we've learned from Sim2H, our centralized server. It's not server, our centralized network switchboard, which we were using because it was too hard to troubleshoot these peer-to-peer network issues. We actually needed to be going through a centralized spot so we could debug our network protocols. And now we've actually done a lot of that, and Sim2H is working extremely efficiently now. We're, when we run these scalability load tests and stuff with 7,500 nodes and that kind of stuff, Sim2H is still not like maxing out CPU on one centralized server that it's going through. So we feel like we've actually gotten a lot of the networking connections and routing and all that type of stuff actually debugged. And so the next step is now to take out the centralized debugger and make them go peer-to-peer. And hopefully that doesn't blow apart some of the performance that we've achieved going through the centralized switchboard at the moment.